Alright, we are good to go. Alright, we're gonna start with the first, in my opinion, the easier paper. Let me fix this. Alright. So we're gonna start with the easier one. Alright, so first we have number one. We're gonna start the problem with the 50 problem. So we have limit as x approaches, sorry for my bad handwriting, -1 of x plus 2. So we just plug it in, you already know, which is equal to 1. Alright, moving on. Moving on to the next one. The limit as x approaches 2. By the way, we're going to go over the other paper as well. The other paper is obviously a lot harder. So these, you're just going to plug them in, nothing too difficult, hopefully. The limit as x approaches 2 of the function 2x. So you just plug in 2 and you get 4. And we're gonna do that. Let's use y instead. 4. We're gonna have the limit of x up as x approaches -3. Well, these problems are really small. -3 cube root x plus 4. And then, you just plug in -3. -3 plus 4 is 1. And the cube root of 1 is just, it could be plus or minus 1, but, let's do 1. Number 5. That was a very bad 5. Number 5, we have the limit as x approaches -2. Of x squared over 2 minus 2x. So you just plug in -2 to x squared and you get 4 over 2. I'm gonna write equals, but I'm gonna write it down here, which is 4 over 2 plus, because -2 times -2 is 4. This is basically 2. So 2 plus 4 is equal to 6. Let me see if I got that right. Number 5, yeah, 6. Alright. Number 6. Like I said, we're gonna just move through this hella quick. Limit as x approaches 2. -x cubed plus 4x squared minus 2, which should be equal to, so that should be -8. And then 4 plus 16, and then minus 2. -8 plus 16, you get 8, and then minus 2, which is equal to 6. And then for number 7, we just go down. Number 7, for the harder ones, I might go a bit slower, but for the most part, I'm just gonna try to go fast. Let me just go back there. Put the limit as x approaches -1 of x plus 2 over x squared plus 7x plus 10. So immediately there's x plus 2 on the top, and we plug in -1 on the bottom. You can plug it in, but it's just a good habit to be able to manipulate algebra. So you just and then you could just factor this with x plus 5 and x plus 2. Cancel that out, both of them, and then you get 1 over x plus 5. You plug in -1, and you get 1 over 4. And if you were to plug in -1 from just here, you would get 1 over, and then -1 squared is just 1 minus 7 plus 10. -7 and 10 gives you 3, plus 1 is also equal to 1 over 4. So It doesn't really matter, but it's just overall it's just better like that. Um, to be able to cancel them out. Number 8 is limit as x approaches -3 of 2x and x plus 2. Like this is one where you could just plug it in. -3, which is going to be -6 on top, and -1, which is just going to give you 6, if I'm not mistaken. Yeah. Let me just use this space over here. Number 9, we have the limit as x approaches -1 of x squared minus x minus 6 over x plus 2. So we could either plug in -1 or we could just manipulate it, so let's just factor the top, which is going to be x minus 3 and x plus 2. And then we have x plus 2 on the bottom, so we could just cancel those out. And then bring it down to just x minus 3. And you plug in -1, and you just get -4, if I'm not wrong. By the way, if you like understand these and you're just looking for a specific problem, just go ahead and I don't know, skip through it. I don't really care. Um, when we can get x as it approaches -2. Um, and then x squared plus 2x. Oh my god, that's really bad. I'm so sorry. Plus 2. Okay. You could do. So this one, we. Okay, okay, you cannot factor the bottom. I just realized you cannot factor the bottom. But, because two numbers that multiply to 2 is just 2 and 1, but that would be x squared plus 3x. So you just plug in -2. So we plug in -2 at the top, we get -3. When we plug in -2 to x squared, which is just 4, I'll just write it out. 4, and then minus 4 plus 2, and these, they cancel, and -3 over 2. Number 11, the limit as x approaches 0 of -x minus 1 all over x squared plus x plus 1. So we obviously cannot factor the bottom, so we just plug in 0. So 0 to the top is just going to give you -1. 0 on the bottom is going to give you 1, so your answer is going to be -1. Number 12, we'll write it over here. We have the limit as x approaches 2 of 2x of x minus 1 is equal to 4. So, actually, sorry. I just looked at my answer and I didn't even try to solve it. Okay. Well, I mean, you could just plug it in. So you have 4 over 1, which is just 4. Um, Number 13, you have the limit as x approaches -1 of x over x squared plus 4x plus 4. Well, it's glitching out. You could just plug in -1, so you just get -1 over. You can simplify the bottom, but we don't have anything on the top, so you wouldn't simplify anything really. And then that would be 1 minus 4 plus 4. So minus 4 plus 4, that's just going to cancel, and we have a 1 at the bottom, so your answer should just be -1. Um, Number 14, let me try to go a little bit faster. The limit as x approaches -1 from the left, so any negative numbers, any numbers less than f of x. I'm not good at drawing these, so of x less than or equal to -1, or the function of 3, which is just x, all numbers greater than -1. So right here, if we had a number line, where's my, okay, this thing, okay, there we go. Let me just erase that. So from the left, if we have the, -1 is over here as x approaches -1, and the negative means from the left, so it's approaching from over here, so it would be, -2, -3, -4. So then x is less than, which means numbers like -2, -3, so we would use this top equation. So we just plug in -1 on the top equation, and we would get 1 plus 4, and that should be equal to 5. Yeah. So then 15, we have the limit as as x approaches 0 from the right of 2x minus 2, which is just equal to -2. You could just plug it in. And we have number 16, which is the limit as x approaches -2 from the right of x over 2 plus 2. You can just plug it in again. -2 over 2 is -1 plus 2, which is just 1. Scroll down. We get a little bit faster with these. The limit as x approaches -2 from the right of x plus 2. You just plug it in. Just get 0. 18. You get limit as x approaches 2 from the right of x plus 1. You just plug it in. 2 plus 1 is equal to 3. Number 19 is limit of x approaching -3. Sorry. I'm so sorry. -3 from the left. Yeah. Of f of x. These take really long to write out. Number 19, x squared plus 6x plus 9 plus 10, sorry, plus 10 of x is less than -3, and 2 x is greater than or equal to -3. You know what, next time I'm probably just gonna write down all the problems so I could just do them instead of having to write them out in front of you. -3 from the left, so any numbers, -4, -5, less than, so it would be the top equation. So then -3, you would get 9 minus 18 plus 10. 9 minus 18 is -9 plus 10, which would just give you 1. We have number 20 of limit as x approaches -2 from the left of -x plus 2, -x of plug it in, you get 2 plus 2, which is equal to 4. 21, the limit as x approaches -1 from the left of f of x, and then the little bracket sign, piecewise function, plus 6x plus 9, comma, x is less than or equal to -1, and -2x plus it's minus 3, and x is greater than 1. So -1 from the left, so it means less numbers, so it would be like -2 and like -3. Sorry if I keep repeating myself, but it's like if you don't get it, then I'm just gonna keep repeating it. -6 and plus 9. Negative 6 plus 9 is 3, plus 1 is equal to 4. um, Sorry, I blanked out. 21 should be 4, right? Yeah. 22, we're barely halfway there, which is kind of crazy. It's taking a lot longer than expected. Plus, then f of x is equal to parallel sine x over 2 minus 2 of x with not the range, the domain x is less than or equal to 0 and 2x plus 3 and x is greater than 0. So we have from the right, so numbers like 1, 2, 3, so it would be greater than. So then we would plug in um, 0 to the bottom one, which would just be equal to 3. Number 23, limit as x approaches negative 2 minus f of x, which is equal to, and then you just draw the bracket. Okay, yeah. Okay, negative 2 from the left. So then it's going to be numbers on the left, and x is numbers less than negative 2 is from the left. So we're just going to plug in negative 2 to the top equation, which is just 4 minus 7, which just gives you negative 3. 24 is the limit as x approaches negative 2 from the left, x minus 2, x squared minus 4. We can factor this. There's a difference of squares. I forgot what Mr. Cisneros calls it. But we have x minus 2 over x minus 2 and x plus 2. And then these cancels, and then you have 1 over x plus 2. You plug in negative 2, and you still get 1 over 0. But we can't have that, so we do our sign analysis test. So we have, this, and negative 2. So we make the vertical asymptote. Vertical asymptote just means that the bottom number can never, x basically can never land in negative 2. It's what a vertical asymptote is, if you didn't know. So this is going to be negative 2. Like, if we plug in negative 2 here, we're plugging in an x value, and this is our x, and up and down is y. So there's going to have an asymptote, which means no number is ever going to land at negative 2, because you're gonna get 0 at the bottom, and you can't do that. But from the left, so we're just gonna grab negative 3, the closest number to it, because I've realized that you can make a mistake if you choose if you try to choose an easier number, but yeah, just stick with the closest number. So you just plug in negative 3, and you're gonna get 1 over negative 3 plus 2, which is just gonna be negative 1. So equal to negative 1, and since we have a negative, that means it's gonna be going down that way. Should look something like this, hopefully. Which means it's gonna be negative infinity, if I'm not wrong. Yeah. Um. So we get 25 with the limit as x approaches negative 1 from the left of negative 2 over x squared minus 1. And then again right here, we could do difference of squares, but it's not really gonna make a difference. So we just do the sign analysis test again. do a negative 1. Sorry, negative 1. We choose negative 2. You put in negative 2, and then you get 2 squared, which is 4. 4 minus 1 is 3 over 2. It's going to be negative 2 over 3. But, you could also do... And the reason that it's negative infinity is because, like, what if you choose negative 1.01? So it's going to be, like, right here, negative 1.01. You're going to have negative 1.01, and you're going to get, like, negative 2 over, like, if you have 1.01 times 1.01, you're going to get, like, 1.001. So 1.001 minus 1 is just going to be 0.001. And how many times does 0.01 fit into negative 2? Like 2,000 times, I'm pretty sure. So it's like, it's going to be negative 2,000, which is going to be like all the way down here, which is why as you get closer, it's going to be reaching negative infinity. It's never going to touch negative 2, but it's going to be reaching towards negative infinity. So number 26, the limit as x approaches like this over x minus 1. You can plug in 1, so you just do a sign analysis test. Once you practice these enough, you can get pretty good at it. Just in your head, from the right, you choose number 2, so then you choose number 2, and you get negative 4. I mean, the negatives from the equation, not the equation, the function. And then 2 over 1, it's just negative 4, which means that's going to be going towards negative infinity. 27. The limit as x approaches 2 from the right, negative x minus 3, x squared minus 5x plus 6. So this, you could factor it out. It would help, yeah, it would help. So let's just factor this out. So then you can have x minus 3 and x minus 2. And these cancel, that means you have negative 1 over x minus 2. But you can't plug in 2. But let's say in our head, we know that you can plug in 2 and you choose it from the right. So then you would choose 3. Let's say we plug in 3, we would get negative 1 over 3 minus 2 is 1. And that's a negative number, so it's going to be negative infinity. So all I did here was just, sign analysis test, 2. And then, from the right, so you're going to just choose the closest number, 3. And then 3 minus 2 is 1. You get it. 28. And as x approaches negative 2 from the left of 1 over x plus 2. So for example, we would do the sign analysis test, negative 2. From the left, so we would choose negative 3. Negative 3 plus 2 is negative 1. 1 over negative 1 is just negative 1. So it should be, and since it's a negative number, it's negative infinity. 29 is limit as x approaches 1 from the left of negative 2x x minus 1. You can't plug it in the bottom, so we do a sign analysis test. Coming from the left, so it would be like negative. No, you could even put 0. I just noticed you can't put 0. No, I don't think you can put 0. Actually, you can. So 0 is, I'm pretty sure, a positive number. I mean, just in case, let's just put negative 1. So if we were to put negative 1, we would have 2 over, um, we would have negative 2 over negative 1 minus negative 2, and then we would get a positive, pretty sure, 29, yeah. I mean, you can just plug in 0. I'm pretty sure 0 is a but don't take my word for that. And then that's infinity. 30. 30 is the limit as x approaches 3 from the right of minus 3x squared minus 9. We have a difference of squares here, but you know, can't do nothing with it. So then from the right, so you could just plug in 4. So then, because it's coming from the right, any numbers from the right, which would be 4, like numbers greater than 3, it would be 16 minus 9, which is just 7. But since it is a negative number, that means it would be approaching negative infinity. 31. The limit as x approaches negative 1 from the left is x minus 1 over x squared plus, oh, I'm doing the wrong one. I'm doing the complete wrong one. 31 is 3 from the right again. 3x over x minus 3 from the right, so you pick a bigger number, so then that would just be 4, so you put 12 over, and then 4 minus 1, 4 minus 3 is 1, and since it's a positive number, that means it's reaching positive infinity. 32, this is the last infinity sign analysis question. Negative 1 from the left of x minus 1 over, oh my god, I keep doing this. Look at the wrong problem. 32 is 1 from the right of 1 over x minus 1, but we can't plug it in, so we choose a bigger number than 1 because it's coming from the right, would be 2. So 1 over 2 minus 1, 2 minus 1 is just 1, so that's a positive number, so it's reaching infinity. Number 33, the one I keep messing up. 33, negative 1 from the left. So then it'll be x minus 1 over x squared plus 2x plus 1. You can't you can factor the bottom one, but it wouldn't simplify. And we can't choose negative 1 because then, it cancel out in the bottom. And it's from the left, so we put in negative 2. So then that would be negative 3 on top. Negative 2 right here would be 4. So it would be minus 4 and then plus 1. So then it would be 0 plus 1, which is 1, is a negative 3, so then it would be negative infinity. Then we have 34 of the limit as, oh, that was really bad, as x approaches 3 of x minus 3, let me scroll down, over x squared minus 5x plus 6. So you can factor x minus 3 of x minus 3 over x minus 2. Cancel, then you have 1 over x minus 2. You plug in 3 and you get 1 over 1, which is just 1. And then 35. Move this paper a bit. 35 is the limit as x approaches 2 of x squared plus x, of x minus 6 over x minus 2. So you can factor this into x plus 3 and x minus 2 over x minus 2. This cancel out. X plus 3. You plug in 2 and you get 5. So like I said, we're going to be going a little bit faster. We just have 14 more problems. We have the limit as x approaches negative 3 of x plus 3 over x plus 3 over x squared plus 2x minus 3. So then we can just factor this. Yeah, we can just factor this. So then we have x plus 3 over x plus 3 and x minus 1. Did I copy that right? Minus 1, sorry. There should be a 1 right here. Yeah, that makes sense. Just cancel negative 1 over x minus 1. Plug in negative 3, and you get 1 over negative 4. So you get 1 over negative 4. But then negative cancels out, and then we have just a 1 over 4. Then we have 37. And 37 is just going to get you the limit as x approaches negative 1 of x squared plus 4x plus 3 and x plus 1. So you can just factor the top from x plus 3, x plus 1. Let's cancel out x plus 3, and you just plug in negative 1, which is going to get you 2. And then 38, you're just going to have the limit as x approaches just 1. And then negative x minus 1 over x squared minus 1. So you could just factor the bottom. So you would have x minus 1, x plus 1. And then you have negative 1 over x plus 1. You just plug in 1. And you get negative 1 over 2. Yeah. Yeah, I'm right. 39. By the way, I make a lot of mistakes sometimes. So I'm sorry if not perfect. X minus 2 over x squared minus 4. Just factor the bottom. X minus 2 over x minus 2 and x plus 2. Just factor out. You have 1 over x plus 2. Just plug in 2. You get 1 over 4. So we have 11 more problems, or 10, I guess. 40, you have the limit as x approaches 1. Sorry, I'm talking so much, I'm losing my breath. And then x minus 1 plus 2x plus 3. Is that plus 3? Oh, no, it's minus 3. Minus 3, so you could just do negative x minus 1 over x plus 3 and x minus 1. Cancels out. Negative 1 over x plus 3, which is going to be negative 1 over 4. Then 41. You're going to have the limit as x approaches 3 of x squared minus 2x minus 3 over x minus 3. Just factor the top into this over x minus 3. Those cancel out. Just have x plus 1. Plug in 3 and you get 4. And you get 41, which is, I think I just did the wrong problem. I did. And this is what I've been doing the wrong problems. I just realized 40 was x minus, no, 41 was 41. Okay, this was supposed to be 43. This is 41. Okay. So 41 is negative, I'm sorry, x squared minus 4x plus 3 and x minus 3. So it's just x minus 3 and x minus 1, x minus 3, x minus 1. I totally forgot to write the limit. I just realized the limit is as x approaches 3. Yeah. Which is just going to give you 2. Yeah. Okay, 40. Did I do 42? I just completely skipped 42, didn't I? I did. Okay, sorry for the mix. X squared minus 3x plus 2 and x minus 1. So then you could just do x minus 2, x minus 1 over x minus 1. Cancel that out. X minus 2, 1, which just gives you negative 1. Then 44. Okay, the limit as x approaches 0 of 5x over 10 of 3x. Okay, so we know the identity that we want is 10x over, I'm pretty sure it's 10x over x that we just want to get 1. No, like sine x over x, that just gives you 1. Um, so from here, but remember that if we flip this, it's the same thing as saying x over 10x is x. If this is equal to 1, that means that, it's 10x is the same thing as x. So if we had 3 over 3 and we flipped it, it would still be 3 over 3. So then right here with 5x, let me write it a bit bigger. So we want 3x to be on top. So we could just multiply this by 3. Oh, my thing is glitching out. By 3, and we could just multiply this bottom one by 3. So we multiply top and bottom. So now you have 3 times 5 times x over 3 times 10, 3x. So the way we could do this is we have a 3 and an x, and we just basically take out the 5. So we would just have 5 and then over, and then we could just get this 3 and then multiply it with 3x over 10. Oh, 10, 3x. So this is just, right here, this is just 1. And then 5 over 3. Hopefully that makes sense. And 45, we have the limit as x approaches 0 of sine 4x over sine 3x. So this, you could just like look and say this is 4 over 3 because sine of ax over sine of bx is a over b. But if you want to show your math, then you could just simply put um I forgot what I was gonna say. Um oh yeah, so you could just do um Oh man, I'm blanking out. So you could just multiply the top one by 1 over 4x and multiply the bottom one by 1 over 4x. I mean, I I kind of do it a little bit differently from Cisneros, I guess. Should be 4x over sine of 3x over 4x. You know, that would turn into 1 right here. And then on this bottom one, you would have 4x. Okay, this just cancels. So you would have 4x over. Because when you have 1 over sine of 3x over 4x, let me go back. Let me erase this. This is the same thing as saying 1 divided by sine 3, so you just multiply by the reciprocal, so it would flip like that. And then you have a 4x at the bottom, and we know that we could just mix and match, so then we just do what we did up here. So it would just be times 3 and times 3, and then that would just be the same thing as saying 3x over sine 3x, and we just get the 3 from here and the 4 from here. 4 over 3, that's just 1, and so we have just 4 over 3 remaining. But do whatever is easiest for you and whatever helps you overall. Then this sine of 4x over 2x, so it's just the same thing, multiply top and bottom by 4. And then we could just rewrite this as sine of 4x over 4x, because you could just do like, you know, this is the same thing as saying 4 times 2 times x, and you could just do 4x times 2. It's the same thing. So then 4x times 2, and then you could just have the 4 up here. And then this turns into 1, and you just have 2. 47, the limit as x approaches 0 of sine squared of 5x over 5x squared. So this, you know, you could just do sine of 5x times sine of 5x, and it's the same thing as saying 5x times x. This is just 1, and then this you multiply top and bottom, then this and that cancel out, and you just have 5 on top from here. 48 would be the limit as x approaches 0 of 1 minus cosine 2x. This identity would just, you know, it's right here, just be 0. You know, just remember the identity of 1 minus cosine x over x gives you 0. It's almost done. Oh, like, okay, I just basically did number 49. So just be 0. Last one, limit as x approaches 0. Right after this, I'm gonna do the harder paper. Let me go. Let me just erase that. Tan of 5x over 2x. So right here we just multiply top and bottom by 5, or 5 over 5x. And we could just write that as 5 over 2 and 5x of tan 5x. That just turned into 1, and we have 5 over 2. So yeah, that's it. I'm gonna go over the next one right now. Sorry if I took long. That took a lot longer than expected. But yeah, let me just stop this.